From ContainerDays Hamburg, this video is proudly presented by DuxIT.
Yeah, API first because life too short for boilerplate. My name is Artur. I'm a software developer from Lufthansa Industry Solutions. We co-authored this presentation with Benedikt. He's also here in audience today. Hi and thank you, Benedikt. In recent years, our company and especially our team has been building microservices in Go and adopting an API-first approach to design and development. Today, I would like to talk about API first, but from more practical perspective. You have probably heard from some developers take like API first slows us down because it means a lot of preparational steps. The truth is it removes rework and boilerplate. Thus becomes a shortcut for better, safer and faster code. And as developers we know life is too short for boilerplate. Let's see what API first means for us developers day to day. Despite the growing influence of AI, vibe coding and other emerging approaches, we still want to have full control over our APIs. From developers' perspective, API first flips the workflow. Instead of writing raw handlers and parsing JSONs, we define the contract once, we generate safe code and let the compiler enforce the contract. The payoff, we were meetings about what the IP should be, we were runtime mismatches and way less glue code. So the question becomes, which tools make it practical in Go and what other benefits could this bring us? Let's ground this in something particular. When people talk about API contracts, the most famous example is OpenAPI, and it's de facto contract format. And in Go, there are several tools to bring an OpenAPI document to life. You can see some of them on the slide. They take different approaches and ideas behind. Some focus on simple code generation and while others offer full framework experience. The point is the Go ecosystem already covers different needs. You don't have to build everything yourself. You just need to understand the tool you pick. And the one I will zoom into today is oapi-codegen, because for us it feels closest to the Go philosophy, simplicity, type safety, less boilerplate in the end. Here below are 4 features that, in our opinion, improve development and development quality and truly help developers. oapi-codegen supports 2 styles of server stubs. Strict server generates typed handlers. Each operation is a method that takes a specific request object and returns a specific response object. That means the compiler enforces the contract. If the spec changes, your code breaks at compile time. You also get clear response types for every case. So success or error handling are always straightforward. Non-strict server, the classical one, emits handlers with familiar response writer and HTTP request pointer. It's more flexible and often the easiest way to get started. Both strict and non-strict modes work well with all major Go HTTP libraries, including Chi, Gin, Echo, and many others. So, rule of thumb. Use strict when you want type-safe edges, clearer reviews, and easier refactors. Use non-strict if you are integrating gradually into legacy systems or need specific control over input-output. Let's move to the next point. Generated code often feels alien, but oapi-codegen supports dozens of X extensions that let our models feel handwritten in Go. Please pay attention to red markers on the slide. Here we map the ID field directly to Mongo object ID type, to native Mongo object ID type with two extensions, xGoType and xGoType import. You can see it marked with red. We also inject specific Mongo underscore ID with extension marked yellow. The result, the spec produce idiomatic Go model. Here, no DTO wrappers, no glue code. We can immediately persist this model in Mongo database without writing a single conversion layer. And now let me move on to overlay feature. That is personally my favorite one. For those who haven't seen overlays before, the overlay specification version 1 was finalized in October 2024. So it's still quite new. Think of them as a patch file for your OpenAPI document. You can update, extend, or even slice it without forking or changing the original document. So I strongly recommend taking a look at the overlay specification, but back to our topic. oapi-codegen already supports overlays. One example how we can use overlay. Sometimes we are on the client side consuming a third-party API. We have no influence on entire API document. They hand us a huge OpenAPI document with hundreds of endpoints. But in our app, we need only one specific endpoint. And we don't want to generate a 10,000 lines client library just for a single call. This is where overlays shine. We apply our overlay that takes only reports endpoints, and then we can tell oapi-codegen, please generate a client only for that tag. The result, a microclient with exactly one endpoint. No forks, no boilerplate, and so no wasted code we don't need to maintain. This brings us to my next point. When open API documentation grows, it often gets split across multiple YAML or JSON files, and by default each file generates its own models. So you end up with multiple models in different packages. Sometimes it's the same models like device, and we have multiple device and device package and report admin and so. So yeah, they are logically the same, but Go treats them as different. Sometimes that's messy. With same package import, we can merge them into a single package. Now there is one canonical model type, no duplication and no import spaghetti. And the nice thing is with oapi-codegen, this is your choice. If you want strong separation of domains, generate multiple packages. If you want shared models and less boilerplate, point them into one. Either way, you stay in control of your project structure. To sum up what we have seen on the previous slides, type-safe handlers that fail at compile type, idiomatic Go models generated from the API document, the way to produce multiple compact artifacts like client servers, docs from a single document. All those things are important for our context and our projects. Your context may differ. Pick tools based on your constraints, like specification version you are on, protocol or broker you use, your team skills, your runtime needs, etc. The key is that the patterns and features travel across tools. With OpenAPI, we used oapi-codegen. For events, the similar contract loop works fine for async API with async API-codegen library. If you live in protobuf gRPC world, tools like buff and ConnectRPC give you the same guarantees. Yeah, even GraphQL follows the idea, schema first, then code generation. Keep the mindset, design the contract, generate and validate, avoid rework, and keep single point of truth. That's what kills boilerplate. And that's it. Thank you for your attention. Now I will be happy to answer your questions.
How would you recommend sharing and versioning OpenAPI schemas between multiple microservices?
Oh.
Maybe a bit too much for 2 minutes, but let's try.
Yeah. Okay. Actually, it always depends on your company standards. Yeah, the classical one, if we use versioning inside of our path, I personally don't like it. In our current project, we use, I guess, we use versioning in headers. So it works well. I would say both option works well, but with path it can be sometimes complicated, and yeah, again depends on tools what you use.
Awesome. 1 minute left, one question coming in. Is there a GUI repo with examples on the topic?
GUI? What? Graphic
user interface? GUI?
You mean, actually I don't understand the word GUI in this context. So right now there is no repo, and you mean slides probably with GUI or what?
Potentially. But maybe this is something the person can come up to you afterwards.
We can discuss it after.
Perfect. That brings me to any other questions. I mean, both you and also Benedikt are still around the whole day, so please feel free to reach out to them.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.